Hi all, welcome back to our YouTube channel. Topic that we will have a look at today is from FRM Level 1. It's from paper 2, that is quantitative analysis. And topic is discrete probability distribution. So on screen, you can see a die because when we talk about discrete probability distribution, the immediate examples that come to our mind is rolling a die or flipping a coin. So, yeah, let's have a look. And yes, before we go ahead, please do subscribe to our channel and like, comment, and share with your friends who are aspiring to have their career in risk management. So, we have been asked to write probability distribution of getting sums of numbers on the faces of dice when two dice are rolled. So, the experiment is such that you are rolling two dice and you're recording the sum of numbers that comes on the faces of dice. Say for example, on the first die it is 1 and on second die it is also 1. So that sum would be 2. So the possible outcome in this case would be 2. Let me make it simple for you by giving example of one die. When you roll one die, there are possibilities over there are uh 1, 2, 3, 6. Just give me a moment. Yeah. Okay. So over there, when you roll one die, the possible outcomes are 1, 2, 3, 4, 5, 6. And all of these outcomes have the equal probability, that is 1 by 6, because total outcomes are 6, and the favorable outcome in each case is 1. So 1 over 6 is a probability. In a similar way, on x-axis, what we have done is we have listed down all the possible outcomes. So when you have one on first die, one on second die, the outcome, that is sum of these two numbers, is 2. And this is the lowest thing that can happen because on die you don't have anything called 0. So the minimum quantity that this event can take is 2 when you have one on first phase and one on another phase. Likewise, the maximum value this experiment can take is 12 when you have 6 and 6 on the both dice. So the outcome is 12, and all the in between numbers are all possible outcomes. So from all the way from 12, all the way from 2 to 12 are all possible outcomes for this given experiment, where you are recording a sum of outcome that comes on the dice. And on y-axis, if you notice, this is a sample space wherein we have list down all the possible outcomes. And on y-axis, we have a corresponding probability, that what is a probability that you will get 2 as a sum of outcomes or 12 as a sum of outcome. It's 1 by 36. How? Let's have a look. So on a first die, you get 1, and on second die, you get 1. So what is the probability of that? So in this bracket, we say that having 1 on this die, and so when I say and, it is termed as a joint probability in the probability space, and usually these probabilities are multiplied. So when you have independent events, your probabilities are multiplied. So getting 1 over 6 on the first die and getting 1 over 6 on the second die is 1 by 6 into 1 by 6, that is 1 by 36. Likewise, Phil, this number 12 has 6 and 6, that is probability of getting 6 is 1 by 6. We saw that when you roll one die, it's 1 over 6 into 1 over 6. So it is the total probability of getting 6 and 6 on both dice is 1 by 36. Likewise, when we can get 3, when you have 1 on the first die and 2 on the second die. Or So over here, like how we saw that this comma was indicating multiplication, this space will signify plus because it's or, because you can get 3 when you have one on first die, second on another die, or. So when or comes into the picture, it's plus. Or when you have second, when you have two on the first die and one on the second die. So in this case, the probabilities would be getting one is probability is 1 by 6, getting 2 is probability 1 by 6. Likewise, there is another possibility wherein you get 3, and the probability of that is also 1 by 6 over 1 by 6. So 1 by 36 plus 1 by 36, it would be 2 by 36, that is 1 by 18. In a similar case, we can argue that probability of getting 4 has these three probabilities, and probability of getting 10 has these three probabilities. So we can have 1 by 36 plus 1 by 36 plus 1 by 36, that is 3 by 36, that is 1 by 12. And for 10 also you can see 1 by 12. And yeah, for 11 it can be similar case for 3. So over here we have 118, we have 1 over 18. Likewise for 5 and 9, there are 4 possible outcomes wherein you get sum as 9, and probability of each outcome is 1 over 36 plus 1 over 36 plus 1 over 36. So 4 over 36, that is 1 by 9. Likewise for 6 and 8, one can argue it's 5 over 36. And for 7, it is there are 6 possible outcomes. So 6 over 36, that is 1 by 6. If you notice carefully, 7 has a highest probability, that is 1 by 6, and followed by 6 and 8. So you see 6 and 8 have probability of 5 over 36, followed by 5 and 9, which have 1 over 9, and likewise 1 over 12 for 10 and 4, and likewise for 12 and 2 and 3 and 11. So this is how the probability distribution is plotted. When we say probability distribution, list down all your possible outcomes and try to come up with probabilities of all those possible outcomes like we have done. We have listed down all the possible outcomes, which were 2 through 12, and their respective probabilities were 1 over 36, 1 over 12, and likewise. And if you notice very carefully, the sum of all the probabilities should be ideally 1. That is a property of probability distribution. So sum of, or if you add up all these probabilities, we get 1. So if you are interested, just bit of maths is over here, because the denominator is not same for all these quantities. To make it same, we have done some adjustments, like to make it uh, 36 over here, we have multiplied 2, so we have to adjust in numerator also. Likewise, when you have to make 12 as 36, you multiply 3, you have to do it in numerator also, so that overall quantity remains 1 over 12. Likewise, for the rest of the fractions also it has been done, and all the denominator have been made 36, and all the numerators quantities are added, and you can validate it that the sum of all the probabilities is 1. Hope you like the video. If yes, please do share with your peers who are preparing for FRM Level 1 exams. Trust me, if you try exploring quants, it's quite interesting. Otherwise, quants is very scary for the people. But if you can have some sort of visualization, you understand how the data is behaving at the back, it would be very interesting for you also. And that's what we try to do over here. We try to stimulate thought process to enhance your learning. We try to make you think, because once you start thinking, that will make your life easier a lot. So yes, please do subscribe to our channel, like and comment also in the comment box. Thank you. Stay connected.